we're going to be doing today is we're going to be defining the trig functions using right triangles. Okay? So let theta be an acute angle. Then we can construct the following right triangle. Okay, so notice here I drew theta here in the bottom left corner, and then I'm labeling the sides. So the side opposite of theta, I'm labeling as op of theta, and the side adjacent of theta, I'm writing adjacent of theta. And then the hypotenuse, hype. So sine, we say, is opposite of theta over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you guys remember your SOHCAHTOA, this is where SOHCAHTOA comes from. We also have three other trig functions: cosecant, secant, and cotangent. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Is adjacent over opposite. Now, one thing I want you to keep in mind, notice I'm starting to drop the of thetas here. Whenever you say opposite or adjacent, remember, it depends on what angle you're looking from. Okay? So be careful about that perspective. One question we can answer now is solving right triangles. So if you're like, what's solving a right triangle? So solving a right triangle just means identifying any angle or all angles in the triangle and all sides of the triangle. Okay, so in this picture here, which I don't know why I wrote theta there to begin with. In this picture, notice we only have one angle and we have one side. So we're missing, and I'm just going to label this C and let's just label this A. We're missing CA in this other angle, which I'll put theta back. I usually start with finding that angle there. Okay, now how do we find the angle? Well, remember, what happens when you add up all the angles in a triangle? Okay, now if you're thinking radians, if you add up all the angles in a triangle, you get pi, or 180. Okay, so pi is equal to pi over 3, this angle right here, plus what's 90 degrees in radians? That's pi over 2, plus theta. Okay, so what is theta? Theta is just pi minus pi over 3, so move both of these over here, minus pi over 2. Okay, we're subtracting fractions, so let's get the same denominators. Okay, and we'll see that we get, in the end, pi over 6. So this other angle here is really just pi over 6. Okay. All right, so the only other two things we have to figure out now are what are the remaining sides. Okay, and again, there's a bunch of ways you can do that. We're going to go ahead and, let's see, let's figure out A first. Actually, no, let's figure out C first. Why not? All right, so C, we're going to use, let's use, and we can use any of these trig functions that we have. Let's use sine. Okay, so we know sine of pi over 3 is equal to the opposite of pi over 3, so that's 4, over the hypotenuse, which is C. Okay, so what does that mean? That means that C, so multiply both sides by C, C sine of pi over 3 is equal to 4. C is equal to 4 over sine of pi over 3. Okay, now what is sine of pi over 3? Sine of pi over 3 is square root 3 over 2. Okay, and then remember, when you divide by a fraction, it's like multiplying by the reciprocal. So this is 4 times 2 over square root of 3, which is 8 over square root 3. Okay, so our hypotenuse in this case is really 8 over the square root of 3. So the last thing we have to figure out, well, what is A? And again, there's a bunch of ways you can do this. You can now use Pythagorean theorem if you want. We're actually going to use, let's use SOHCAHTOA again, but let's use cosine. And actually, I'm going to go ahead and erase this work over here because I'm running out of room. So cosine of, let's say, pi over 3 is equal to the adjacent of pi over 3. So A in this case over the hypotenuse, 8 over the square root of 3. Okay, so cross multiply. 8 over the square root of 3 times cosine of theta, cosine of pi over 3 is a. Now, what is cosine of pi over 3? Cosine of pi over 3 is 1/2. Remember, look at your unit circles if you don't remember that. And so simplifying, 2 goes into 8 4 times, so this is really just 4 over the square root of 3. So this is 4 over the square root of 3. And we've solved this right triangle. Now, I do want to point out, and I was saying this as we were doing this, there are multiple ways of doing this. We have all the other trig functions that we could have used in this case. I was just using sine and cosine. But again, there's a lot of ways you can do it. Okay, so just keep that in mind. All right, if theta is between 0 and 90 degrees, okay, so this means it's an acute angle, and sine of theta is equal to 3 over 5, find the remaining 5 trig values of theta. Now, what this means right here, the 5 remaining trig values, a trig value is just literally a trig function on whatever angle you're talking about. Okay, so the trig values of theta are sine of theta, cosine of theta, tangent of theta, and so on and so forth. Okay. So in this question, we know that sine of theta is 3 over 5. Okay. So how do we find the rest of them? Well, let's remember our SOHCAHTOA, right? Let's construct a right triangle. And now we know that sine of theta is opposite over hypotenuse, right? So we get these as those two sides, and now we can figure out that the remaining side is 4. And if you're curious, this is the work for that. And now once we have this, we're actually good to go. So what's cosine of theta now? Cosine of theta is adjacent over hypotenuse, so 4 over 5. Tangent is opposite over adjacent, 3 over 4. Okay. Cosecant of theta is hypotenuse over opposite. Secant of theta is adjacent. I'm sorry, hypotenuse over adjacent. And cotangent is adjacent over opposite. Okay? So once you have that right triangle, you're actually really, really good to go with these trig values. We define these trig functions actually gives us a lot of identities or relationships between our trig functions. The first kind of relationships, and hopefully we all know and love this, and I think we saw this in an earlier video, tangent of theta is actually also equal to sine of theta over cosine of theta. And similarly, cotangent is cosine over sine. These are what we call the quotient identities because tangent is being written as a quotient, cotangent is being written as a quotient. Additionally, we also get what's known as the reciprocal identities. Okay, and reciprocal, it's 1 over something. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangents, 1 over tangent. So these are the quotient identities. Now be careful. Cosecant goes with sine here, and secant goes with cosine. When I was an undergrad, I used to think it was the other way around because I wanted S's to go with S's and C's to go with C's, but it's the other way around. Cosecant sine, secant is cosine. And then another important identity that we'll be using this off and on throughout the rest of the videos is the Pythagorean identities. And if you take anything away from identities, this is the one I want you guys to remember the most because it's one of the most useful identities we have in trig. And the Pythagorean identity says 1 is equal to sine squared theta plus cosine squared theta. Now I'm going to show you really quick, and this is kind of a preview for trig identities, which we'll get into in a later video. I want to show you guys how we come up with this. Okay, how is sine squared plus cosine squared equal to 1? Okay, so what we're going to do is we're going to start with the right-hand side, sine squared plus cosine squared, okay, which is what I have here in this first line right here. Now, how did we define sine and cosine? Sine was opposite over hypotenuse, so we have opposite squared over hypotenuse squared, plus, how did we define cosine here? That's adjacent over hypotenuse, so we get adjacent squared over hypotenuse squared. And now if we add the fractions, notice we have the same denominator, so we can add. Okay, so we'll get opposite squared plus adjacent squared over hypotenuse squared. And now to get 1, because where does 1 come from? Let me draw a triangle really quick. So this is theta. This is the opposite of theta. This is adjacent of theta. And this is the hypotenuse. Okay. Now, what does the Pythagorean theorem tell us? The Pythagorean theorem tells us that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Okay. Now look at the numerator. What do we have here? We have exactly that, the opposite squared plus the adjacent squared. So what is the top actually equal to? It's actually equal to the hypotenuse squared. So this is hyp squared over hyp squared, which is 1. Okay. So this is, again, what we call the Pythagorean identity. And we're going to be using this off and on in our next videos. We also have 2 other Pythagorean identities which you can get from the first Pythagorean identity we talked about. First one is secant squared is equal to 1 plus tangent squared, and cosecant squared is equal to 1 plus cotangent squared. Okay. If you have to remember any of the identities, though, I recommend knowing this the first one. That's the most important. You can get the other ones from this one. And also, I will say in Calc 2, this identity is pretty helpful as well. All right. Last question for the day. If theta is in quadrant 2 and sine of theta is equal to 1 over 5, find the remaining trig values of theta. Okay. Now, in this case, we have to be a little bit careful, but I want you guys to think about this. Theta is in quadrant 2. Okay. So we think back to our unit circle, that means that theta is over here. Okay. Somewhere over here. So, how do we figure out the other remaining trig values? Well, notice that we just learned about the Pythagorean theorem, right? 1 is equal to sine squared theta plus cosine squared theta. So we can actually use this to figure out cosine, because what do we know in this problem? We know that sine of theta is 1/5. So we get 1 is equal to 1/5 squared plus cosine squared theta. Okay. 1 is equal to, what's 1/5 squared? That's 1 over 25. Okay, subtract 1 over 25. You're going to get 24 over 25 is equal to cosine squared theta. And then take the square root of both sides. And remember, don't forget your plus or minus. It's plus or minus the square root of 24 over 25, which is plus or minus the square root of 24 over 5. Okay. Now we have to think about it. Remember, these are functions, right? So you can only have one output. Which is it? Is it plus or minus? And how we determine this is, remember, theta is in quadrant 2. So if theta is in quadrant 2, think back to your unit circle. Is cosine positive or negative there? Okay. And since it's in quadrant 2, it's actually negative. So it's negative square root 24 over 5. Okay. So now we have cosine. Cosine of theta is negative square root 24 over 5. Now that we have this, we're actually in good shape. Using our other ideas, we can figure out functions of tangent theta, sine and cosine. Okay, so that would be, let's see, sine was 1 over 5 divided by negative square root 24 over 5. Again, remember, if you divide by a fraction, it's like multiplying by the reciprocal. 5's cancel out, and we're left with negative 1 over square root of 24. Okay, if we want to figure out cosecant of theta, remember that's 1 over sine of theta. So 1 over 5, that's just 5. Secant of theta is 1 over cosine of theta. So 1 over negative square root 24 over 5. That becomes negative 5 over square root 24. And then cotangent, we could use that that's cosine over sine, but remember cotangent's also 1 over tangent, right? So just flip tangent, And you're going to get that cotangent of theta is negative square root 24.